Hello, 6th grade. In the last video, we talked about how to multiply fractions together using a visual method, and we did that by drawing rectangles and dividing them into fourths, fifths, etc., and then shading the individual cells within those rectangles to try to visualize what it really means to multiply two fractions together. In this video, we're going to learn the more traditional method for multiplying two fractions, and that is going to be the arithmetic rules for how you multiply fractions together. So, when we're multiplying two fractions together, step one is that we multiply the numerators together. Step two is to multiply the denominators together, and step three is to reduce them if necessary. One thing about multiplying fractions that is a lot different from adding and subtracting fractions is you do not need common denominators when you're multiplying two fractions together. So let's look at this example here, 5/8 times 4/5. In order to multiply 5/8 times 4/5, I'm going to first multiply my two numerators together, so 5 times 4. Then I'm going to multiply my two denominators together, 8 times 5. 5 times 4 is 20, and 8 times 5 is 40, and so I get the fraction 20 over 40. My last step is to reduce whenever necessary. 20 and 40 are both even, so I know that they're both divisible by at least 2. I can also take 10 into 20 and 10 into 40. So I can divide both 20 and 40 by 10 to get the fraction 2/4. 2/4 is still reducible. I can divide both the top and the bottom of this fraction by 2 to get the fraction 1/2. So my answer to this problem, 5/8 times 4/5, is the fraction 1/2. Oftentimes you will find it is a lot easier to reduce before you actually multiply. And if you do this process, which I'm going to show you in this next example, we often refer to it as canceling. So if I had the two fractions 3/5 times 10/15, again, to multiply these two fractions together, I would multiply my numerators, 3 times 10, and then I would multiply my denominators, 5 times 15. If you look at the numerators and the denominators here, you see we have a 10 at the top and a 5 at the bottom. I know that 10 and 5 are both divisible by 5, so I can do this process of canceling to reduce my fraction before I actually multiply. And I'm going to do that by dividing 10 by 5, which will leave me with a 2, and 5 by 5, which will replace my 5 with a 1. So what I did right here is I divided 5 and 10 both by 5 to replace them with a 1 and a 2. I can also do that with my 3 and my 15. You see that 3 and 15 are both divisible by 3. So if I divide 3 by 3, I'm left over with a 1 in its place. And if I divide 15 by 3, I'm left over with a 5. So I can do this process called canceling to make my numbers here a little bit smaller. So now I have a 1 times 2 in my numerator, and I have a 1 times 5 in my denominator. 1 times 2 is 2, 1 times 5 is 5, and so this gives me the answer of 2/5. So that's another way to multiply fractions, is to do your reducing or your canceling in the middle before you actually go through and multiply. Now let's try a few more examples. So going to the next one, we have 2/3 times 4/5. Again, I'm going to multiply my numerators, 2 times 4, and my denominators, 3 times 5. I'm going to look to see if I can do any canceling. I have 2 and 4 on the top, okay, and I have a 3 and 5 on the bottom. Nothing on the top is divisible by the same thing as anything on the bottom, so I'm just going to multiply like normal. On the top, 2 times 4 will give me 8, and on the bottom, 3 times 5 will give me 15. 8 over 15 is non-reducible, so my answer to this problem is 8/15. The next one, I have 3/5 times 5/6. So my numerators are 3 and 5. So I'll have a 3 times 5 up top. My denominators are 5 and 6. So I'll have a 5 times 6 on the bottom. On this one, you can see that I have a 5 on the top and a 5 on the bottom. 5 and 5 are both divisible by 5, so I can divide this 5 by 5 and replace it with a 1, and do the same thing on the bottom. Divide by 5 and replace that with a 1. I also have a 3 on the top and a 6 on the bottom. So I can divide this 3 by 3 and replace it with 1. I can divide this 6 by 3 and replace it with 2. So I can do some canceling for this problem to make my numbers a little bit smaller. So now I have 1 times 1 in my numerator, and in my denominator I have 1 times 2. 1 times 1 is going to give me a 1 on the top. 1 times 2 will give me a 2 on the bottom. So my answer to this fraction problem is 1/2. My last problem is a word problem. It says that Frank had half of the lawn left to mow. On Saturday, he mowed 2/3 of what was left. What fraction of the entire lawn did Frank mow on Saturday? For word problems, a lot of times it's best to just draw a picture so you can get a visual idea of what's going on in the problem. So let's draw a picture of our lawn. So here's the lawn that Frank has to mow. And at the beginning of the problem, it tells me that Frank had half of the lawn left to mow. So we're going to take the fraction 1/2 and we'll just divide our lawn here into halves. Okay, so that means that Frank has to mow half of this lawn. So we'll just say that this is the piece right here that Frank still has to mow. The next part of our problem says that on Saturday, Frank mowed 2/3 of what was left. Well, remember, of is our little keyword for multiplication when we're dealing with fractions. So we know this problem is going to involve multiplication. It says that he mowed 2/3 of what was left. So if I divide this part here into thirds, he's mowed this part and this part on Saturday. And so the question's asking, what fraction of the entire lawn did Frank mow on Saturday? So the question is asking, what fraction of our entire rectangle are the two pieces that I've drawn in purple? Well, we can see that visually by seeing that now I've drawn my rectangle into 6 equal pieces, and I have 2 of them shaded in. So I can think of that as the fraction 2 out of 6. But I can also do that using my multiplication. I know that we started out with 1/2 of the lawn, and now we're taking that times 2/3 of the lawn. So if I use the multiplication rules that we just learned, we're going to take our numerators times each other, 1 times 2, over my denominators, 2 times 3. I have a 2 on the top and a 2 on the bottom. I can divide both these 2's by 2 and replace them with a 1 and a 1. So now I have 1 times 1 over 1 times 3. 1 times 1 is 1. 1 times 3 is 3. So I get the fraction 1/3 here. I get the same fraction if I reduce my 2/6 over here. 2 over 6 reduces to 1/3. So I can see either way, either by drawing my visual diagram of the lawn or by doing this fraction multiplication of 1/2 times 2/3, I get the same answer of 1/3. So that means that Frank mowed 1/3 of the entire lawn on Saturday. As always, if you have any questions over this video, be sure to jot those down, and you can either email me those before I return to class or ask me when I return, And until I see you again, have a nice day. You're all wonderful people, and take care.